So that concludes our course on the greatest unsolved mysteries of the universe. We've talked about 9 of the great puzzles that keep astronomers up at night and keep us in work.
Well, Paul, we've done 9 great mysteries, but that's not really all of them.
No, there are indeed a great number of other unsolved mysteries of the universe. For example, we know that Mars used to have water. We see the water channels on it from lots of NASA and other space probes. That implies in the past it must have been warmer than it is now. But in fact, the sun is getting brighter according to our understanding of stellar physics. The sun would actually have been 30% fainter in the past. If anything, Mars should be cooler in the past than it is now. So how come it was warmer? I mean, that's a puzzle.
Yeah, one of the other things in my area is we really don't understand why supernovae themselves explode. We have vague ideas, but we really don't understand it in detail.
Yeah, like where do magnetic fields come from? The magnetic field in the sun and the Earth probably came from original magnetic fields that have been regenerated by the dynamo, but where did the original seed magnetic fields come from that have been kept going all this time?
We don't know, why neutrinos have mass. That's another area that really is a bit of a mystery.
And in my own research, I've been looking at the tails of comets that are a very long way from the sun, and I thought this is something that should be very well understood. So I embarked on this research project and discovered they all pointed the wrong directions. In fact, they point two wrong directions. They go around hooks when they stick out, which is a bit weird.
Okay. So there's a lot more in the universe that we need to know about. So don't think that just this course is all there is.
Now, Brian, let's say you're someone starting out looking to become a researcher in astronomy. How would you go about picking a field to work on? You clearly need an unsolved mystery to work on. Should you try and figure out why the Big Bang happened?
Well, I think that you really want to try to figure out something that you're passionate about. Because when you have a passion about something, that's what you really want to do with all your heart. And when you want to do something with all your heart, you do it incredibly well. So at some level, if it excites you, it probably is going to excite other people, and you're certainly going to be able to excite them. So I always say, do something that you really want to do and make sure that you can explain it to your grandmother, because if you understand something well enough, you can always explain it to your grandmother.
But there's also a sort of balancing act here. There are the problems that are really interesting, like where did the Big Bang come from, but if you try and solve that one, you're going to bounce. It's just too hard, the current status. And then there are problems that are really small and solvable, like exactly how many B5 stars are there in the constellation of Orion.
Yep.
Yes, you can answer that, but who cares? So presumably there's some sort of balancing act here. You've got to pick things that are both interesting enough, but doable.
It's certainly true, but I do contend that if it's something you really, really, really want to do, you will by nature pick the right problem, the ones that are doable, that you're excited about and you want to work on. If you try to solve why did the Big Bang happen, you're just going to stare at a blank wall and bang your head against it. It's too big of a question. Kind of hard to be excited about that.
Also, there's an advantage to having a field where you have some sort of competitive edge. Like there are a lot of very smart astronomers out there, and a lot of any topic that's obvious has probably been done by somebody. How do you go about getting that sort of competitive edge for yourself?
Well, certainly one of the really important things is to be looking at technology and how it's advancing and what areas of astronomy it opens up. And so in my case, in 1994, we had big new telescopes and we had large digital detectors. And those allowed us for the first times to look at distant exploding stars. And so that technology enabled a new area or a new ability to answer a huge question. And so you don't necessarily have to develop the technology yourself, although that's good if you can, but you need to always be looking out for the new opportunities, because if you're on the edge, then you're on the cutting edge. And that allows you to do things that go where no one else has gone before.
So if you'd had the brilliant idea, let's use type 1a supernova to measure the expansion rate of the universe and how it changed 10 years earlier, you couldn't have done it.
Yeah, and people tried and they failed.
And 10 years later, it would have been done already.
Exactly. So there is a just-in-time approach. That concludes the first part of our course on the outstanding mysteries of the universe.
We'll now continue on to the next part of the course, which will deal with exoplanets, planets around other stars.